Now, another very interesting things that happen when you talk about simulation is the term behavior. Different people will look at the same situation and react differently. And it's funny because people say humans, at least some of them, are intelligent agents, make the best decisions. So why do people behave differently if they are interesting agents? And why do the people act differently in the same situation? If it's rain, many people will go around and dance in the rain. Many others will say, oh my god, I need to go home, it's already late and I'm not doing it. It's raining, sorry, I'm not doing it. So, different people ultimately have different objective functions in life. What's the objective of life is a philosophical issue. Nobody has been able to comprehend it up. At a career level, at a local level, joys of life, preferences in the world, type of food that you like, everybody has different objectives. And what happens is that people react differently. Some are more aggressive, some are more socializing, some do not want to take any risk, some are entrepreneurs. Let's take a risk. Some are more careful. So, every person actually has a different behavior. And for a single person also, with time and situation, the behavior will change. Now, where does behavior come into play over here? In decision making, so you've got the system where the agents reads by sensors and acts with the help of actuators in an environment, and the agent of course now has a rule base, and I've said that it may not be if else rules, it can be a mathematical expression, neural network, whatever. Now this rule base, it governs your behavior in the form of actual rules, in the form of the parameters of the rules, in the form of some additional rules, but that is what encodes your behavior and it encodes what you do. And therefore, in a simulated world, you could have many agents which differ from the rule base, differ in terms of the parameters of the rules base, and act differently, which is best as per their own understanding, as per their own objectives, as per their own behavior. And that is what we say is a behavioral modeling of all the agents. So, potentially I could have thousands of agents and each one of them has a slightly different behavior which is governed by the different parameters of the rule base. Multi-agent plus behavior does something which is extremely interesting. So if I've got multiple agents and I'm discussing behavior, the behaviors could be of two types. One is cooperative and the other one is competitive. So cooperative, we are all a team, and those are the type of simulations that we do where there's a single objective and everybody tries to get towards that objective as a team. We're not dealing it as AI at a deliberative level, we're dealing it in a reactive level. So looking at whatever things are going around, you need to decide for yourself and say, how do I act so that I contribute to this team? FIFA, everybody is playing their own match and they are together having a collaboration with each other. The opponent team, you are competitive in nature. Now, it really happens is that are humans cooperative or they are competitive? It cannot be said. It absolutely cannot be said. When I give an assignment to a cooperative, all the solutions are flowing around. When it's placement time, the company says there's only one position, you fight with your peers, you become competitive suddenly. Uh, the two systems do not have a fuzzy definition as well. Strictly speaking, a system is competitive if my win is definitely your loss and your win is definitely my loss. It's also called as a zero sum. So my score in life plus your score in life is zero. Football, if I win by 2 goals, you lose by 2 goals. Boxing, I win by 5 points, so you lose by 5 points. The sum of returns is zero. It's cooperative when your score is my score. So, cricket match, we are part of the same team. Both of us win, both of us lose. We are part of the same team. So it's not like maximizing my points or your points. It's maximizing our points, and there's no clear boundary between the two. So, speaking about behaviors, traffic, is it cooperative or is it competitive? Some people would say that it definitely is a competitive system, and it is a competitive system because you're traveling, especially in India, on a road with a reasonable speed. Somebody behind wants to overtake you, you don't get aside, lower your speed, let it pass by, and then go around. It's competitive. But people do that. So, humans are cooperative agents. You know that I'm nicely traveling with my own preferred speed. A person who is driving fast comes from behind. I do not know why I step aside. It happens naturally. We are cooperative agents. It's bad for me. It's increasing my travel time. It's increasing my travel cost. And this person goes. Real cooperative. People offer seats to ladies. Cooperation. Your pains will hurt. But it's also competitive. If there's a parking space for only one, there are two people, you don't say to the other person, okay, you do it, you fight for the spot. If there's only one seat, it's a 3-hour journey, you fight for your seat. So we're also competitive, and that's exactly what happens when the standard definition don't hold good. So in each one of them, there's nothing like our score, and there's nothing like my score and your score together becomes a zero. If I give aside how much, a few seconds my travel time will increase, I don't actually mind that. So, on the other hand, if I let this person overtake, it will actually have a lot of returns to this person because his travel time can reduce from 3 hours to 2 hours, which is 33% reduction, which is actually great. So the sum of the two utilities is not zero, the sum of the returns is not zero, so you give a little of yours for the other one to go. That's exactly why we do charity as well. So the little charity that you give is small as compared to you, but it makes a bigger difference in somebody else's life. The sum of the returns is not zero, it's not a zero sum game. So even though it was otherwise competitive, you cooperate a little bit so as to trade off between what losses it causes to you and what benefit it causes to the other. And that is what we will be considering, the multi-agent behaviors. And just a quick note, so again, it could be done at a deliberative level, it could be done at a reactive level. So we've already seen cooperative searches in the course on AI, those joint spaces, the joint state spaces of all the agents and the agents acting of it. And here we looked at Minimax. So now we'll basically be looking at into different senses the reactive way of being cooperative and the reactive way of being competitive, and what happens when you actually do that. We also covered a learning based system for both in the AI course, which was the reinforcement learning, of course. So we looked at how the agent could learn how to play a game, not doing all those calculations in mind, and could learn how to cooperate in the course of AI. In this course, we'll just make in some reactive rules so that the agents together display these kinds of attributes and properties. Now, talking about behaviors, let me take in one last example, and these are type of examples that I'll be taking for a long time. So that's what is my agent. Say it's a robot. This is what are obstacles, and this is what is a goal. So one type of behavior is what is called as goal seeking. It goes here. That is what happens as goal seeking behavior. The agent wants to go to the goal. The other one is there's an obstacle around over here, so I need to go here. This is called as an obstacle avoidance behavior. And what really happens is the sensor input comes over here, both the behaviors get invoked, and they all tell the robot to what to do, what not to do, and you've got a fusion of the two, which is situation aware, and that is your output. So when you have multiple behaviors, that's what happens. A part of you says be aggressive, a part of you says be careful, a part of you says do this thing, a part of you says do that thing, and different behaviors suggest different actions, and there's your conscious which says that okay, in this situation this appears to be a good choice, in this situation that appears to be a good choice. Had it been so and so, I would have done something different. For this behavior, there's a known way of fusion. Near the obstacles, you're more obstacle conscious, so you go with obstacle avoidance. Far away from the obstacle, you are more goal loving and you go towards the goal, and that's what causes the fusion. So obstacle avoidance tries to give you a motion vector which is away from the obstacle. Goal seeking tries to give you a vector which is towards the goal. They may not agree, they don't agree. And the fusion mechanism, it either tries to take a weighted addition of the two, that okay, let me say 90% I go with goal seeking and 20% I go with obstacle avoidance based on a context which is I'm far away from obstacles. Sometimes it does a selection that okay, let me just select that in this type of situation this behavior is good to display, and sometimes all it says is that out of all the behaviors only these behaviors are valid. Like there may be that aggression behavior, it's not there because that punching is a behavior when you find your enemy, and out of the behaviors which are active, then you decide that okay, let me take a fusion or a selection that is context aware. Let's add up in another interesting thing. So you've got another agent over here. So this is agent 1 and this is what is agent 2. And looking at the way it is going, I know that this agent intends to go somewhere around here. So this is a goal for agent 2. Now you may have additional behaviors like I can cooperate and go here so that it's two fat people. It's like me and Pawan Chakravarti. So we won't fit in unless we move aside, and this has a cooperative behavior here. So you could have a cooperative behavior around over here, or what you could do is you could have an aggressive behavior here. I don't care about you, I'll go swarming. That's what happens when I'm getting late for class, even if it's there's Pawan Chakravarti. I tell him, I don't care, I'll just run. I fail to look around, I'll just run. So, there are different behaviors that you could happen, and you decide based on the behavior whether one gets selected or they get fused by weighted addition, and that's exactly what we'll be doing in this course. The sensor reading will invoke different kinds of behaviors simultaneously, and we will let the behaviors get selected, fused, interacted, and overall we'll see that when both the agents select their behavior, what drama happens. They could block each other, they could fight with each other, they could cooperatively avoid each other. One could be aggressive but later on may turn meek because it has a look that the other person is not behaving, so let it pass by. Multiple things could happen.